In the presence of light or at high temperatures, alkanes react with halogens to form alkyl halides. Reactions with chlorine gives an alkyl chloride. Reaction with bromine gives an alkyl bromide. Unsaturated hydrocarbons such as alkenes and alkynes are much more reactive than the parent alkanes. Alkanes, the most basic of all organic compounds, undergo very few reactions. The two reactions of more importance is combustion and halogenation. Substitution of a single hydrogen on the alkane for a single halogen to form a halocane. The halogen reaction is very important in organic chemistry because it opens a gateway to further chemical reaction. Combustion, complete combustion given sufficient oxygen of any hydrocarbon produces carbon dioxide and water. It is quite important that you can write properly balanced equation for these reactions because they often come up as a part of thermochemistry calculations. Some are easier than others. For example, with alkanes, the ones with an even number of carbon atoms are marginally harder than those with an odd number. Provided the combustion is complete, all the hydrocarbons will burn with a blue flame. However, combustion tends to be less complete as the number of carbon atoms in the molecules rises. That means that the bigger the hydrocarbon, the more likely you are to get a yellow smoky flame. Incomplete combustions, where there is not enough oxygen present, can lead to the formation of carbon-carbon monoxide. As a simple way of thinking about it, the hydrogen in the hydrocarbon gets the first chance at the oxygen, and the carbon gets whatever is left over. The presence of glowing carbon particles in a flame turns it yellow, and black carbon is often visible in the smoke. Carbon monoxide is produced as a colorless poisonous gas. Halogenation is the replacement of one or more hydrogen atoms in an organic compound by a halogen, fluorine, chlorine, bromine, and iodine. Unlike the complex transformation of combustion, the halogenation of an alkane appears to be a simple substitution reaction in which a CH bond is broken and new CX bond is formed. The interesting reaction happens in the presence of ultraviolet light. Sunlight will do. These are photochemical reactions that happens at room temperature. We'll look at the reaction with chlorine, although the reaction with bromine are similar but evolve more slowly. Substitution reaction happen in which hydrogen atoms in the methane are replaced one at a time by chlorine atoms. Alkanes. The most characteristic reaction of alkanes is addition to the carbon-carbon double bond in such way that the pi bond is broken and in its place sigma bonds are formed. Alkanes undergo a wide variety of reactions. At first glance, these reactions appear to be quite different, but detailed studies indicate that the different mechanisms are all share some common features. The double bond is the reactive center of alkane. This is mainly because of the relative closely held electrons of the double bond. The bond is formed by side-by-side overlapping, relatively weak overlapping mode so the bond is weak and exhibits high reactivity. The electrons also make the double bond carbon electron rich and have the tendency to be attracted to the electrophile. The high reactive makes alkanes an important type of organic compound, and they can be used to synthesize a wide variety of other compounds such as halide, alcohol, ethers, and alkanes. The most common type of reaction for alkane is the addition reaction to a C equals C double bond. In addition reaction, a small molecule is added to multiple bonds, and one bond is converted to two bonds, and saturation degree decreases as a result of the addition. An addition reaction is the opposite process of elimination. Addition of HBr, HCl, and HI. The addition of these substances to an alkane proceeds by an ionic mechanism with formation of the most stable carbocation. Therefore, it follows Markovnikov's rule. Acid catalyzed addition of water produces Markovnikov alcohols. It is an equilibrium reaction and proceeds with formation of carbocation in the rate determining step. Oxymercuration demercuration sequence. This sequence consists of two steps. It is the most effective way to prepare Markovnikov alcohol from alkanes. Hydrocarburation oxidation sequence. This sequence also consists of two steps. It is the most effective way to prepare anti-Markovnikov alcohols from alkanes. The components of water add to the bond with site stereochemistry of chiral centers. Result from this reaction, the product is obtained as an antimeric as an in anti as an enantiomeric mixture. Halogen addition. This reaction is performed most frequently with bromine and chlorine. It adds a halogen atom to each of the two carbon comprising the bond with anti-stereochemistry. If chiral centers result for these reactions, the product is obtained as an isomeric mixture. Halogen addition in the presence of water. Halogen formation produces Markovnikov alcohol with neighboring halogen. The OH and the halogen add with anti-stereochemistry. If chiral centers result for this reaction, the product is obtained as an antitomeric mixture. Hydroxylation adds two hydroxyl groups across the bond with stereochemistry. It can be performed with two reagent mixture, potassium permanganate in basic medium or osmium tetraoxide in the presence of hydrogen peroxide. If chiral centers result from this reaction, the product is obtained as an enantiomeric mixture. Anti-hydrolation sequence add two hydroxyl groups across the bond with anti-karyochemistry. It proceeds in two steps via epoxide, three-membered right ether. If chiral centers result from these reactions, the product is obtained as an enantiomeric mixture. Catalytic hydrogenation adds hydrogen across the bond with stereochemistry. It basically transforms an alkane into an alkane. alkanes, the principal reaction of alkanes is addition across the triple band to form alkanes. These addition reactions are analogs to those of alkanes. Hydrogenation alkanes undergo catalytic hydrogenation with some catalysts used in alkane hydrogenation: platinum, palladium, nickel, and rhodium. Reactions of alkanes: alkyl alkylation of terminal alkanes. Alkylation is addition of an alkyl group to a molecule which can be alkane. Terminal alkanes can undergo alkylation reaction because the H atom of them is somewhat acidic and therefore willing to donate its proton. The H atom of terminal alkane is removed by a relatively strong base. Reduction of alkanes, both terminal and internal alkanes, may undergo reduction reaction which add molecules of hydrogen across double and triple bonds. You better be wearing your safety glasses when you run this reaction because hydrogen gas is very flammable.